Assalamualaikum and very good morning. My name is Noorfazlida binti Muhammad from Faculty of Engineering, CEH 950 Campus Permanent Tampau, and supervised by Engineer Dr. Jumain Jalil. For this defense of research proposal, I would like to present my study title, which is Synergetic Hybrid of Propylene Glycol, METHYL Acetate, PMA, and xylene for water-based epoxy coating technology to prevent corrosion on industrial tank. For introduction, what this study about? This study is purposely to develop a epoxy coating formulation with less hazardous than current commercial epoxy coating while maintaining or improve the corrosion properties, since corrosion is the major problem that affect most industrial worldwide. It will affect the global economy. Why this study conducted? This study conducted because we have intention to reduce or eliminate the solvent use, since it will give a bad impact on health and environment. But at the same time, solvent give a strong performance on industrial application that make it still relevant until now, even though many people or organizations have concern about their bad impact. How we design the experimental data. In this study, we designing by using the Taguchi method. The Taguchi method will use to design the experimental run with 5 parameters, which are the percentage of water, xylene, PMA, resin, and pigment. Then, the analytical technique used including salt spray for corrosion, GCMS for VOC determination, FTIR for chemical group, and SEM for morphology of paint formulation. For the background of the study, corrosion is admitted as a major problem that affected most industries worldwide, including chemical industries, mining, metal, food and beverage, energy, water, wastewater, and many more. One of the corrosion-resistant or protective approach is to apply linings and coating as a barriers. Nowadays, some common protective coating used are solvent-based coating, which give a bad impact on health and environment. The movement to reduce or eliminate the impact is by replacing the hazardous solvent to water-based coating or by high solid coating, which are not using much solvent. The challenge is, for the moment, the technical performance of water-based is behind the solvent-based version. However, by introducing the mixture of xylene and PMA will offer the great alternative to water-based coating with similar performance. For the problem statement, industrial tanks are responsible for collecting and storing various fluids, including water, wastewater, and many more. However, the storage tank, like metal component, is susceptible to corrosion damage and lead to significant compromise the tank structure integrity. Leaks and spill contaminated the stored fluid leads to fire and explosion. Epoxy coating with a high degree of cross-linking and the nature of the interchange bonds give many desired characteristics, including excellent addition to many substrates, high strength, which is the tensile, comparative, and flexural, have a good chemical resistance, good fatigue resistance, good corrosion resistance, and electrical resistance. This study focused on the application to prevent corrosion on tank in industry using epoxy coating as a tank lining. Objective of this study, we have 4 main objectives. The first one is to investigate the comparative study of water-borne epoxy coating system for industrial coating to prevent corrosion using PMA and xylene. The second one is to determine the best process parameter using synergetic hybrid of PMA and xylene for water-borne epoxy coating technology using Taguchi optimization method. The third one is to investigate the effect of PMA and xylene, pigment and resin percentage toward the effectiveness of corrosion. The last one is to investigate the physical chemical properties of synergetic hybrid of PMA and xylene in waterborne epoxy coating. The scope and limitation. The limitation of this study limited to 5 parameters considered in the total formulation, such as percentage content of water, PMA, xylene, pigment, and resin. The experiment will conduct in open system using stirring machine. Machine start with the pre-disperse step, disperse and until get desired fineness. The third one is the corrosion response measured by the salt spray result. It is accordingly with the ISO 9227-2012. The fourth one is the analytical measure using including the GSMS, FTIR, and SEM. Significant contribution of this study is by successful of this formulation, we can save millions of dollars annually for industry upon preserve their asset from the corrosion damage, have a significant impact on natural environment, human health, and the economy, conserve and restore natural sources. For the novelty, for the process, epoxy coating available in the market mostly in solvent-based system, and by replacing solvent as diluent to more ecological diluent like water and PMA will address this gap. For the body of the knowledge, it focus on the method to prevent the corrosion, and the investigate data will use to overcome the corrosion issues arising from the industrial tank. Challenge for ours as academician is to get the enough and complete data on formulation, while challenge within the industry player is to maintain or improve properties at a reasonable cost, while at the same time meeting the needs for environmental friendly coating. Then for the application, it will use on industrial tank, and the industrial tank will sustain more longer. For for the literature review, this is the industrial major problem is the corrosion. As on the picture here, the A picture is showing that the corrosion on the ground tank. The next B, the corrosion on the inner surface of the tank, and the third C is the outer surface of the tank. Corrosion mechanism. Okay, according to ISO 9044 standard, corrosion is defined as the physical chemical interaction between a metal and environment that leading to modification of cation of metal properties and lead to significant alteration of the metal function. The transfer of electron is possible because the metal are conductive through the metal from ionic region to cationic region and form the corrosion product. Coating as a corrosion prevention. Coating have a special abilities including ability to resist water, chemical, abrasion, weather, bacteria, fungus, and extreme temperature. Epoxy coating. Epoxy coating mainly widely used in marine coating, protective coating, and in other application fields since this coating exhibit excellent adhesion, corrosion resistant, and chemical resistant. For the research methodology, the chemical use 5, which is the epoxy resin GEL R128. The second one is the epoxy curing agent jointmine 900C. This is also called as a hardener to harden the film film. The third one is the pigment, which is rutile titanium dioxide R6618. The fourth one, the additives such as deformer, rheology modifier, and leveling agent. Then the important one is the diluent solvent xylene and PMA. For experimental setup, we have the stage pre-disperse, disperse, and the grinding. For the pre-disperse stage, it takes about 20 to 30 minutes. It will combine epoxy resin, diluent, PMA, and xylene, and water, and rheology modifier. After all well mixed, the speed increase until get the temperature 50 to 60 degrees C to activate. At this stage, we are adding the titanium dioxide, the pigment, and the additive used like the deformer and the leveling agent. Sandmin ground is putting back the certain amount of epoxy resin diluent in the formulation. Then for the grinding fineness, we check the fineness until get below than 100 micron. Then it will pass and can produce the finish as a part A. Only at the epoxy curing agent when to apply. Optimization by Taguchi method. Reaction condition, we have 5 parameter: water, PMA, xylene, pigment, resin, and we have 4 level. For the diluent, water, PMA, and xylene, we start from 0, 10, 20, and 30. For the pigment, we start from the 10, 20, 30, 40, and for the resin, we start from the 20, 30, 40, 50%. By using these 5 parameter and 4 level, the Taguchi method will design the orthogonal array, which is the sequence of experiment. The total experiment need to run is 16 run. Within the 16 run, we can get the one optimum condition. The optimum condition we'll use to validate the test. Okay, expected result. For this expected result, the first one is corrosion result. Result of salt spray used to determine which formulation are most effective to prevent corrosion. The second one is the VOC content determination by using GCMS. It used to identify the VOC content at optimal condition. The third one is FTIR to identify the chemical identity of the used material. The fourth one is the air morphology in order to analyze the microstructure of the coating layer. The fifth one is to get the effect of optimum condition at every parameters. It will measure the response of each parameter and level used. And then the sixth one is the chemical, physical and chemical properties. The test, the series of tests included the finest applicable period until the VOC content. This test will identify either the performance of water base and solvent base is similar or comparable. For the Gantt chart, this is my study Gantt chart for the first year. For the first year, I managed to do the literature review, design the experiment, do some analytical, and ongoing do the thesis. For the second year, continue do the literature review, continue experimental run, continue the experimental analysis and data collection. And on the second year, we started to do the analytical measure and the physical chemical properties checks. For the third year, we have I think I can done all the experimental runs, all experimental analytical measure, but on that time maybe some continue on the physical chemical properties check, and after that focusing on the writing thesis. Okay, that's all from me. Thank you.